The planned Mars missions by China and Russia set for the 2030s represent a pivotal moment in the arena of international space exploration, posing significant challenges to the United States' long-standing dominance in this field. China's Tianwen-3 mission is on track for a 2030 launch with the goal of returning samples from Mars by 2031. Concurrently, Russia's Mars mission, though less detailed, is expected to unfold around the same period, potentially culminating in a sample return as well. China's Tianwen-3 mission. China's Tianwen-3 mission is advancing with a strategic approach that emphasizes a streamlined architecture compared to NASA's Mars Sample Return (MSR) mission. The mission will consist of two long March 5 launches, one for a lander and ascent vehicle and the other for an orbiter and return module. The lander is designed to utilize a robotic arm and drill to collect Martian surface samples. With discussions ongoing about the inclusion of a rover or helicopter for enhanced sample collection capabilities. As of recent updates, China has revised its launch target from 2028 to 2030, which means the mission will miss the optimal launch window for Mars by 26 months, pushing the timeline for the return of samples to Earth to 2031. The mission's success could substantially advance China's capabilities in planetary science and astrobiology. 3 primary landing sites have been identified for the Tianwen-3 mission: Amazonas Planitia, Utopia Planitia, and Chryse Planitia. Research has suggested that Chryse Planitia is the most promising site due to its geological diversity and historical signs of water, which could offer insights into past life on Mars. The mission's technical challenges are considerable, particularly the collection of rock samples, the ascent from Mars' surface, and the rendezvous and docking process in Martian orbit. China's previous successes with the Tianwen-1 mission and the Chang'e 5 lunar sample return have bolstered their confidence in tackling these challenges. The anticipated findings from Tianwen-3 could provide critical information regarding the potential for past life on Mars. Russia's Mars mission. Russia's plans for a Mars mission are still evolving, but it is expected that they will also pursue a sample return mission around 2031. As details continue to emerge, Russia's growing space capabilities could complicate the competitive landscape, particularly if they achieve significant milestones that precede those of the US or China. Implications for US dominance. The US is currently grappling with challenges related to its MSR mission, which has faced budgetary constraints and scheduling issues. Concerns are mounting that delays in US efforts could allow China or Russia to achieve key milestones first, potentially undermining the US's leadership in planetary science. The planetary science decadal surveys have underscored the urgency of returning Martian samples as a critical priority for the US to maintain its dominance and foster international cooperation. The competitive dynamics of these upcoming Mars missions could reshape geopolitical relationships in space exploration. Both China and Russia's advancements may lead to a shift in the international perception of US capabilities, particularly if they successfully execute their missions. Common themes and critical insights. Both China and Russia are making strides in their respective Mars missions, which could challenge US preeminence in space exploration. China's Tianwen-3 mission is on a promising trajectory, although recent updates have indicated a potential delay. The global emphasis on astrobiological research and sample return missions highlights their critical importance for scientific discovery and geopolitical positioning. In comparing the sources of information, one emphasizes the competitive implications of the upcoming Mars missions, while the other provides detailed insights into China's mission architecture, landing sites, and technical plans. Timeline of key events. 2023. China announces significant progress on the Tianwen-3 mission, targeting a launch around 2030. 2024. The US reassesses its Mars sample return mission due to financial and scheduling concerns. 2030. Planned launch for China's Tianwen-3 mission. 2031. Expected return of Martian samples from Tianwen-3 and potential launch of Russia's Mars mission. Conclusion. The unfolding space race towards Mars between China, Russia, and the United States is set to have far-reaching implications. not only for scientific advancements but also for national prestige and geopolitical dynamics. As both China and Russia advance their Mars missions, the US may find itself at a crossroads, needing to reassess its strategies to maintain its leadership in planetary science. The outcome of these missions will not only contribute to our understanding of Mars but could also redefine the landscape of international space exploration for years to come. The international landscape of space exploration is evolving, particularly with the planned Mars missions by China and Russia, which are set for launch in the 2030s. These efforts are significant as they could alter the balance of power in space exploration traditionally dominated by the United States. Counterintuitive information. 1. China's simplified architecture versus US complexity. At first glance, one might assume that a more complex mission architecture, such as NASA's Mars Sample Return (MSR), would inherently yield better results. However, China's Tianwen-3 mission is designed with a simpler architecture that could allow for a more straightforward execution. This could actually enable China to achieve its goals more efficiently, potentially challenging the US's position despite its more complicated plans. 2. Delayed launch versus competitive advantage. Although China's recent timeline indicates a delay from 2028 to 2030 for launching Tianwen-3, this could be seen as a setback. However, the counterintuitive aspect here is that this delay might not significantly hinder China's competitive positioning. It still allows them to leverage existing technologies and experience from their Tianwen-1 mission, possibly leading to a successful sample return that could precede US efforts. 3. Russia's ambiguity. The uncertainty surrounding Russia's Mars mission could seem like a disadvantage, however. This lack of detailed information might also allow Russia to operate with a degree of strategic ambiguity. If they can execute their plans effectively without revealing too much detail, they could potentially surprise both China and the US with their advancements, thereby altering the competitive dynamics unexpectedly. 4. US budget constraints as a competitive weakness. The US is facing significant budgetary constraints that are delaying the MSR mission. This situation is counterintuitive because the US has historically been the leader in space exploration. The decline in its financial commitment could embolden nations like China and Russia to invest more heavily in their programs, leading to a shift in leadership in planetary science and exploration. 5. Astrobiological research as a geopolitical tool. The pursuit of astrobiological knowledge is typically viewed as a scientific endeavor, however. Its implications for national prestige and geopolitical positioning are profound. The possibility of discovering biosignatures or signs of past life could serve as a powerful tool for national pride and international influence, making the scientific race a significant political issue. 6. The role of sample return missions. While sample return missions are deemed critical for scientific advancement, they also serve a strategic purpose. The urgency expressed in the Planetary Science Decadal surveys about returning Martian samples underlines a dual objective: advancing scientific knowledge while simultaneously maintaining US dominance. This intertwining of science and strategy might not be as apparent when discussing the missions purely from a scientific perspective. 7. Perceived technological superiority. The belief that the US possesses superior technology in space exploration is being challenged by the rapid advancements made by China and Russia. This perception could lead to complacency in the US space program, while in reality, the capabilities of the other nations are accelerating. The potential for China or Russia to achieve significant milestones before the US could flip the narrative of technological leadership. 8. Geopolitical implications of success. The success of either China or Russia in their Mars missions could foster a new era of geopolitical dynamics. Rather than simply being a race for scientific achievement, these missions could reshape alliances, encourage competition, and alter global perceptions of power in a way that transcends traditional military or economic dominance. In summary, the upcoming Mars missions by China and Russia are poised to create significant shifts in the international landscape of space exploration, challenging US dominance in unexpected ways. The interplay of simplified mission architectures, strategic ambiguity, budget constraints, And the intertwining of scientific goals with geopolitical ambitions all present a complex and counterintuitive picture of the future of space exploration. The outcome of these missions could not only advance scientific knowledge but also redefine international relations and power structures in the 21st century. The impending Mars missions by China and Russia set for the 2030s hold significant implications for the competitive landscape of international space exploration, particularly regarding U.S. dominance in the field. While many observers focus on the technological and scientific aspects of these missions, there are critical elements in the reports that could be easily overlooked which may shape future geopolitical and scientific dynamics. Key overlooked elements. 1. Strategic timing and launch windows. The reports indicate that China's Tianwen-3 mission now aims for a launch in 2030, which will miss the ideal launch window for Mars, pushing the mission's timeline back by 26 months. This delay could give the U.S., which is currently reassessing its Mars sample return MSR mission, a crucial opportunity to regain its competitive edge. The significance of launch windows in planetary exploration cannot be overstated. They are dictated by orbital mechanics, and missing them can lead to extended delays. Understanding the implications of this timing could provide insight into the U.S.'s ability to capitalize on potential setbacks faced by its competitors. 2. Geopolitical implications of Mars sample return. The potential scientific discoveries from the Mars sample return missions, especially regarding the search for past life, could have profound implications for national prestige and international relations. A successful mission by either China or Russia could bolster their standings as leaders in space exploration, challenging the narrative of U.S. dominance. This is significant because scientific achievements in space often translate into soft power, enhancing a nation's influence on the global stage. Thus, the outcomes of these missions could reshape alliances and rivalries, making the competition about more than just scientific discovery. 3. Technological simplicity versus complexity. China's approach to its Tianwen-3 mission is characterized by a simpler architecture compared to NASA's MSR mission. While modern space exploration thrives on complex systems, the significance of a simpler, more reliable mission architecture should not be underestimated. This could enable China to execute its mission more successfully, minimizing risks associated with technological failures that often accompany complex systems. The ability to deliver results using a less complicated design could serve as a model for future missions and influence how other nations approach their space programs. 4. Landing site selection. The reports highlight the significance of the chosen landing sites for the Tianwen-3 mission, particularly Chryse Planitia, which has shown geological diversity and evidence of past water. The implications of selecting a scientifically rich landing site are profound, as this could enhance the likelihood of discovering biosignatures or geological evidence of past life. The importance of astrobiological research in these missions reflects a broader trend in international space exploration, where scientific objectives are closely tied to national interests and prestige. The implications of successful sample return from a site deemed historically significant could further cement China's role as a leader in astrobiology. 5. Challenges in U.S. space exploration. The U.S. is currently facing budget and scheduling issues with its MSR mission, which could lead to significant setbacks. The focus on these challenges can overshadow the urgent need for strategic adjustments to maintain leadership in planetary science. If the U.S. cannot navigate these obstacles effectively, it risks ceding ground to China and Russia. This situation emphasizes the need for robust funding and strategic planning in NASA's future endeavors, highlighting how domestic issues can have international repercussions. 6. The role of international cooperation. The Planetary Science Decadal Surveys underscore the importance of international cooperation in planetary exploration. However, the competitive nature of space exploration between the US, China, and Russia raises questions about the feasibility of collaborative efforts. The significance of fostering international partnerships in space exploration should not be overlooked, as shared scientific objectives could mitigate geopolitical tensions and enhance scientific outcomes. This is particularly crucial in an era where collaboration could lead to more comprehensive understandings of planetary science. Conclusion. The upcoming Mars missions by China and Russia are not merely technical endeavors but pivotal moments that could redefine geopolitical dynamics and scientific leadership in space exploration. The significance of timing, strategic considerations, technological choices, and the potential for international cooperation are critical aspects that deserve more attention. As these missions unfold, they will serve as a litmus test for U.S. leadership in planetary science and could have lasting implications for global space exploration. Understanding these nuances is essential for grasping the broader implications of the current competitive landscape in space exploration. 1. Emerging competitive landscape in space exploration. The upcoming Mars missions by China and Russia signify a shift in the competitive dynamics of space exploration historically dominated by the United States. China's Tianwen-3 mission targeting a 2030 launch and Russia's anticipated mission in 2031 highlight the increasing capabilities and ambitions of these nations. This competition raises concerns about the U.S.'s ability to maintain its leadership position in planetary science and exploration. The implications extend beyond just scientific achievements; they encompass national prestige, technological advancements, and geopolitical influence in an era where space exploration is increasingly viewed as a measure of national power. 2. Technical innovations and strategic planning. China's Tianwen-3 mission exemplifies a strategic approach to space exploration focusing on a simpler yet effective architecture compared to NASA's Mars Sample Return (MSR) mission. The mission's design involves two Long March 5 launches utilizing advanced technologies developed from previous missions like Tianwen-1 and Chang'e 5. The selection of landing sites, particularly Chryse Planitia, underscores a meticulous planning process aimed at maximizing scientific returns while ensuring mission safety. This focus on technical innovation and strategic planning could give China a competitive edge, especially if they achieve significant milestones ahead of the US or Russia. 3. Geopolitical implications and U.S. challenges. The challenges faced by the U.S. in its Mars Sample Return mission, particularly concerning budgetary constraints and scheduling issues, could undermine its leadership in planetary science. The planetary science decadal surveys have emphasized the urgency of returning Martian samples to maintain U.S. dominance and foster international cooperation. If China or Russia successfully conducts their Mars missions ahead of the US, it may shift the balance of power in space exploration, impacting international collaborations and the strategic positioning of these nations within the global arena. 4. Scientific significance and astrobiological research. The scientific implications of these Mars missions are profound, particularly concerning astrobiological research. Both China and the U.S. recognize the importance of returning Martian samples to understand the planet's geological history and the potential for past or present life. The successful return of samples could yield critical insights into Mars' past environments, contributing to our understanding of planetary processes and the potential for life beyond Earth. This highlights the broader significance of space exploration in addressing fundamental questions about life in the universe and the shared scientific objectives that transcend national boundaries. 1. The space race 1950s to 1970s. The Cold War era marked a significant period of competition between the United States and the Soviet Union in space exploration. The launch of Sputnik 1 by the USSR in 1957 ignited fears in the US about Soviet technological superiority. This led to the establishment of NASA and a series of missions culminating in the Apollo moon landings. The intense rivalry not only showcased technological advancements but also had profound implications for national prestige and global political dynamics. 2. The European colonization of the Americas 15th to 17th centuries. The arrival of European powers in the Americas, particularly the Spanish and the British, marked a critical period of competition for territorial dominance and resource acquisition. This era saw significant geopolitical shifts as nations vied for control over land resources and influence. The outcomes of these conquests shaped the political landscape of the New World and had lasting impacts on indigenous populations and global trade networks. 3. The Opium Wars 1839–1842 and 1856–1860. The Opium Wars between Britain and China were pivotal conflicts arising from trade disputes, imperial ambitions, and the impact of opium on Chinese society. The First Opium War resulted in the Treaty of Nanking, which ceded Hong Kong to Britain and opened several Chinese ports to foreign trade. These events exemplified the clash of imperial powers and the significant geopolitical shifts that arose from economic competition and territorial expansion, influencing international relations for decades. The competitive landscape of space exploration is entering a pivotal phase as China and Russia gear up for their Mars missions in the early 2030s. China's Tianwen-3 mission, targeting a launch in 2030 and a sample return in 2031, is poised to challenge U.S. dominance in planetary science. Meanwhile, Russia's plans, although less defined, are expected to coincide closely with China's timeline, further intensifying the competition. China's Tianwen-3 mission. China's Tianwen-3 mission is a significant step forward for its space program, building on the success of Tianwen-1, which successfully deployed a rover on Mars in 2021. The Tianwen-3 mission is designed to collect and return Martian samples, a feat that underscores China's growing capabilities in space exploration. The mission architecture involves two Long March 5 rocket launches, one for a lander and ascent vehicle, and another for an orbiter and return module. The mission aims to utilize advanced technologies such as a robotic arm and drill for sample collection, potentially supplemented by a rover or helicopter for enhanced operational capacity. China's rigorous planning indicates a focus on landing sites with geological diversity, particularly Chryse Planitia, which is thought to hold clues about the planet's watery past and potential for life. The success of this mission could not only advance scientific knowledge but also solidify China's status as a leader in space exploration. Russia's Mars mission. In contrast, details surrounding Russia's Mars mission remain sparse, but expectations are high for a sample return mission planned around 2031. Historically, Russia has significant experience in space endeavors, and a successful Mars mission would represent a resurgence in its space ambitions. The implications of a successful Russian mission could complicate the competitive dynamics further, especially if it achieves key milestones ahead of the US or China. Implications for US dominance. The US currently faces challenges with its Mars Sample Return (MSR) mission, which is experiencing budgetary constraints and scheduling issues. The planetary science decadal surveys have emphasized the urgency of returning Martian samples as a priority for maintaining US leadership in space exploration. As China and Russia prepare their missions, the risk of falling behind in this space race becomes more pronounced. The potential for either China or Russia to achieve significant milestones before the US raises concerns about the erosion of American leadership in planetary science and international collaboration in space. The successful return of Martian samples by either nation could shift the narrative of space exploration, positioning them as leaders in scientific research and discovery. The geopolitical landscape. The unfolding space race toward Mars is not just a matter of scientific achievement, it carries substantial geopolitical implications. The ability to return samples from Mars would not only enhance a nation's scientific prestige but also its soft power on the global stage. Countries that lead in space exploration often position themselves favorably in international negotiations and collaborations. As nations compete for dominance in space, this rivalry could spur greater investments in science and technology, leading to advancements that benefit humanity as a whole. However, it also raises the specter of increased militarization of space and potential conflicts over resources and technological supremacy. Future outlook. Looking ahead, the international landscape of space exploration will likely become increasingly competitive, with China and Russia positioning themselves as formidable players as both nations advance their Mars missions. the U.S. will need to reassess its strategies to maintain its leadership role. This may involve increased funding for NASA public-private partnerships and an emphasis on international collaboration to foster a cooperative rather than confrontational approach to space exploration. In conclusion, the Mars missions planned by China and Russia for the 2030s represent a critical juncture in the international landscape of space exploration. As these nations pursue ambitious goals, the implications for U.S. dominance in planetary science and the broader geopolitical dynamics will be profound. The outcomes of these missions could reshape the future of space exploration and establish new power dynamics in the realm of scientific discovery.